Okay, so we're gonna wait a few moments to make sure YouTube is live. And it looks like YouTube is ready to go. So this is I decided to do this because I had time. Don't feel that you need to be here live. Hopefully, there's plenty of information if you play this back. Let's see. Feel free to subscribe, leave a like. Kind of want to reach out to more people to disperse this information a little bit better. But we'll see how it goes. So today, so I was able to do some iBert eye scans with the Synergy transceiver loopback. So we can look at the eye scan for that. I just have one sample. I did several eye scans of different rates and whatnot, and overall it did pretty good, especially with the equalizer on. As soon as the equalizer was on, it had no errors. It was error free. I'm going to be using the transceiver breakout with some UFL cables in the future to get all the parts. It's probably going to take a few weeks, but I'll redo the iBert test there, and we'll actually run through how I do it. We'll do a whole video stream of the iBert test, how we generate it, what the different configurations are, and how we can go through that. I'm going to have to read up on that to be more knowledgeable, but that'll be good. Then we're going to go look at what the board store has, the pull request on that for doing the new board. Then we're going to try to do a design in Vivado using the new board. And then we're going to try, with that design, to do a MicroBlaze DDR test. That's kind of our agenda today. So the first thing first, let's go look at that eye scan. So this is an eye scan. This was done with Perbs 31, max power with the EQ equalizer on. I was playing around. I did lots of different ones, but this is overall like a good eye. Was the equalizer on? The equalizer might have been off for this one. I think it was on. But overall, did very good. Oh, my other screen went black. Ah, there it's back. Oh, probably have to check out the USB cable there. But yeah, did fairly good there. But yeah, so 16 gigabits. I was on Discord with the FPJ subreddit. Some people were concerned that this port would only handle 5 gigabits or 5 gigahertz, which I think is actually 10 gigabits per second. They can handle 5 gigahertz clock, but it can handle a 10 gigabit per second data line. But I wanted just to show that it can do the full 16 gigabit line rate that is advertised for the Arctic's FPGA. Okay, so what we're going to do next, while this is open, we're going to open my most recent example. And while that's refreshing, we're going to go through the pull requests. So there's been a few pull requests to get the board file on. So we're going to just look at the ones suggested to file. We have a change log. This is about the Ethernet, JSON. With that, I'm gonna have to check that video cable later. That's the camera expansion card. Here's the PCIe expansion card. So here, let's see. What did they? I think we're on the correct version. I'm gonna have to check which version we are. If I can find the correct files. That's what it used to be. Where's they got rid of that? What's this file look like now? Not helpful. Okay, so we go to code. Let's go to the pull requests, are the branch we care about. Boards, Opal Kelly. This guy, 1.1. We should make sure we have the 1.1. So this is a term that I think is causing us issue. Let's see if we can find that in our files. So we go to Vivado 2020.1 and data. Wasn't an X hub, the X hub boards. Do they not? Installed it. Do you not have the XEM8320 anywhere? Why that's searching. So this is what I think is causing us an issue. Also, do the LEDs? The LEDs don't have an I/O standard, which was also causing a fun issue as well. They don't have like a little magical statement that covers that, do they? So those, I think, are the two main things that are upsetting my build. So we'll figure that out. I don't think any of their patches changed anything. They were just fixing things. So I think we're still going to have an issue here. But so I was able to build the board. So we're going to, while we try to get the other build working, we're going to play with this working build where all I had to do was work on the clock and the LEDs. So the I/O standard. I can show you my screen file as soon as this opens up. Oh, we want that one. So we have DDR and LEDs. That's kind of all this design is, and it works, and it's great. So we'll play around with the Vitis tools to do a DDR test with this. But first, let's try to build one from the ground up. Let's go ahead and do a new file. AOP, we're going to do board files 00. Just try to get the board files to work. RTL project, yeah, boards, Opal Kelly. So we do have the correct version. We don't have any of the, so you can click connections and they have, oh, these starter kits and whatnot. We don't have these things. I guess I could install those, but we won't install those right now because I learned not to mess with the board store while you guys are watching over stream. So let's go ahead and hit next. We want to export that one and start working on Vitis. So let's go and try to do this the official way. Let's try to do this the way it was intended to be used. Those are all parts I don't really care about. So we go over the board, right? So let's go ahead and add a MicroBlaze real quick. MicroBlaze. We want 64K bytes. We want a UART debug. New clocking wizard. That sounds right. Yeah, make sure you have the Kintex parts. Let's go over here. Board files, make sure you have the Kintex UltraScale Plus parts installed as well. There's dependencies for the RTX UltraScale Plus parts. Don't worry about licensing. You just need the parts downloaded to your machine. It's not going into demand parts. Okay, let's do a. We're just gonna hit this up. We want to do that on the fabric clock. This is how you should use the board files. At least how I think you should do the board files. I don't know how they want us to do it. I'm gonna turn the reset off. I don't need a reset in these designs. We don't have a reset. Where do I connect the reset? I don't know. Then we have a reset right there. So what we're gonna do, add a constant, and we're gonna call this not that. We're gonna call this a const1, and we're gonna connect it. Yay! Cool. Now we can go to the fun part. Hit the DDR SDRAM and add it to a mid controller. And so pre-configure. Let's go look. We'll look at the DDR settings. It should be set up to 2600 speeds. First, let's do the connection. The Axie bus, sure. System reset, we'll deal with that later. So if we click the DDR, right? Connected to the board interfaces, the speeds. So this is our thing. So we're running at 2666. Is there anything else we can set on this that we should care about? Let's see. That's all good. No clamshell. You could change this if you want. This sometimes optimizes better based upon the program you're running. Axie options. Yeah, I don't see any issues there. Advanced clocking. You can have external clocks here, so you can generate external clocks off your DDR clock if you want. It's like a PLL. We don't need IO planning, so we're good there. So we're gonna take the const 1 right here, and we're going to call it a. I'm gonna set it to 0 real quick. 0. And where'd it go? We're gonna rename it to const 0. And then we're gonna plug that into system reset. This is already good. We're already good. And then we're gonna attach the LEDs with GPIO. That's fine. Run the connection automation. Sure, that'll attach to our AXI bus interface. Boom, we're good. Check the addresses. We have 1 gig there. Yeah, that seems solid. We're gonna validate this. We're gonna let it generate bitstream. It's gonna fail maybe. We'll come back. We'll save the error code to send to Opal Kelly and see what they think. But yeah, validate it, save it. Go over here. Oh, I was gonna show you the constraint file. So let's look at the constraint files real quick that I had to do. So this is a design that's working. And basically I manually picked out the clocks and I had IO standard to the LEDs. That's what I had to do. Let's see what we can do here. Oh, it's gonna be Verilog. Oh well, that's fine. The VHDL file. Seems good, seems good. We're gonna generate bitstream. Let it go. Let it rip. While that's generating, it'll take a second, but as soon as it's done generating, we're gonna go over to this file. We're going to export it and then open Vitis. Then we're gonna turn this guy on. Open up the front panel so we can at least hopefully that clock. Okay, you guys don't hear the clock. That's good. Looking at my inputs. Hey, they're doing a nice job of cutting out the clock. Okay. As soon as those launches are done, I guess we can send that to the background, but it has to, as soon as it gets into the out of context build. Okay, I think we're good. So we're gonna go file. We want to export hardware. Include the bitstream. AU25 MP. Next. Finish. Okay, sweet. There's no way to open Vitis from here, right? Launch Vitis IDE. Here we go. Sometimes it's harder to do that. I like it when the SDK would grab your stuff automatically. So yeah, let's do a small MicroBlaze Vitis tutorial today. We'll do a hello world, do a MicroBlaze application. Actually, we'll probably just go straight to the MicroBlaze application for the DDR one. Let me pick a appropriate folder for this SDK off screen real quick. Sometimes I don't feel comfortable showing you guys my file directory several times during a stream. Okay, we're gonna launch. Nothing like Vitis taking a bit of time. Okay, we're here, right? We're going to create an application project. Create a new platform from an XSA. Oh, we're gonna browse for it. Directory. Again, showing you guys my directory. Hopefully, sensitive on that. Otherwise, I would be sad. Invalid application name. We're going to do an MBDDR application. Yeah, sounds good. MicroBlaze standalone. We want to do a memory test. So first thing first, let's go to platform. Modify the BSP. So we go to standalone. We see that the standard in standard out is on the MDM, which is what we want to do. Beautiful. Okay. Go to source, memory test. We should see this. Okay, let's build this guy. We're just going to build our BSP first, our platform, I guess. Platform support package or board support package? Yeah, confusing. Changing up these names on me. Okay, let's see how this board file went. So its synthesis is going well. Should be on to implementation fairly soon. That finished. Let's go ahead and build this project. Yep. So what we're going to do is we're going to right click this and we're going to say run as launch hardware. Exactly where it is. See, JTAG slow. JTAG slow. Front panel not slow. Not slow. Look at that. No way you're running that long. We have memory ranges. Where's the size? We have the size. Testing memory controller. This. Size is this. Range. Open this real quick. I want to do something. Open declaration. I want to test words, right? Pattern subtest. That's how many words we're doing. So let's go back to this guy right here. So it's only doing that many words. That's a 4K bytes. Let's do 4 megabytes. 1024 times that. Right. Let's do bytes. Yeah, 4 megabytes. And then times 256 for the final one. That sounds right. Okay, let's rebuild. So first save, rebuild. Okay, so let's do something fun. Let us embed this into the FPGA. So we're gonna do Xilinx. Where's my? Is it right? Launch. Where is my program bit file? When you don't know, I mean, this is a new one, right? I don't know everything. Program device. There we go. What we want to do is browse. Is the ELF file not there? Where's my ELF? Browse. I want that ELF. Okay, thank you. And then we're going to try to download this through the faster system. So right now it's taking the BRAM that's located in the instruction set of the processor, and it's rewriting the DDR up to the processor. Reset that cable. Buy a better cable. Okay, so it's a little bit different. So let's try this, right? So we see that thing right here. What we're going to do is now we're going to crawl back into my up folder. Ow. Go to our workspace, MicroBlaze DDR, debug. No. It's going to be in the hardware. What was just generated? Where is our bit? Okay, it's going to be MicroBlaze underscore IDE. So go back here. We're gonna go MicroBlaze DDR underscore IDE bitstream. Download it. So fast. Why am I missing that? Missing this whole. Okay. So should we try a gig? Is it gonna rebuild it? Be like it's out of date. You need to rebuild. I feel like it should have solved that, but I don't know. I don't think it rebuilt it. Uh, project. It's actually words, not bytes in that situation. Okay, so we're doing pretty good here. How are we doing in our board files? So we're at the op design stage. I love it when you have a good error at the end. Maybe, we'll try to do some LED stuff. It'll be fun. Good. So in this situation, how long it's going to take. The MicroBlaze is testing the entire DDR. Unfortunately, that might take a while. Yeah, I mean, the last one was, what, sub a minute, and this is 256 times it. So, yeah, it could be a few minutes. We won't worry about that. Okay. Let's see. That screen keeps going out. I have to change out the USB for that. There's not much to wait for as we. This is the hardest thing about live streaming and FPGA development, right? It can take a while. Don't get me wrong, this was clearly excessive. Like, yeah, let's go ahead and kill it. And the best way to kill it is just to be like, well, whoop, we're going to reprogram it real quick. So yeah, let's go ahead, pull up a tickle. Shell Vivado 2021. There we go. Let's pull up a tickle shell. Go play with the tickle shell. Why we wait for the end of days? So we're going to connect JTAG targets. Ooh. I feel like the B-scan switches new. Targets. We have a MicroBlaze, so we're going to target 3. Let's go look at the location for our address range. So we want to look at the GPIO. Okay, here we go. We got a fail. So we want to record this error message. So this right here is what we want to record. We want to copy the message, put that into a Notepad++ to send to Opal Kelly. After this, boom. Now what we're going to do is open block diagram. We're going to go to DDR. We're going to say, we're going to pick a custom interface. Hit OK. And we go to the board, we're not using that clock anymore. So this will, so we're going to save this. We're going to open side, we're going to run synthesis. Hit OK. And then we're going to give it the attributes that we need. Actually, I need anything. I'm just going to create a constraint file. Down here. This is that better. But yeah, so address of our GPIO. Thank you. Okay, the address of our GPIO was 4,000. So that should be fairly easy. So we do a memory read. LEDs. Okay, sorry. Of 4,000, or you know that address. Oh, we can read it. Now we are going to write to it. Write to it. Oh, okay. 4 LEDs came on, so we can, you know, be able to do fun little patterns. Cool. So we have control of LEDs. Cool. This is all through the JTAG port, not through the USB-C port. It'd be cool if we could do that stuff through the USB-C port. So let's go ahead and add a constraint file here. So if anyone else wants to, just to say the rest of this video is probably boring. I'm gonna be debugging the board file so I can send my bugs to Opal Kelly. But yeah, so don't expect too much more out of our out of this stream per se. Open up please. We do clock P. What? Hopefully this doesn't take too long. It looks like we just have one of them working. Ugh. Besides that, I don't see any viewers at the moment. Let's see. The viewers are hidden. We'll say something, right? We'll chat. I'll go over here. What? I'll put in the chat. So okay, put that in the chat. We'll see if anyone pops up. Ah, look at that. So back to our board files. We should get some music or something. Okay, down there. They'll be starting soon. Let's see. What else is there to talk about? You could talk about some of the cables and whatnot I'm getting. So let's open up a tab here so I can set up the links. So let's go ahead and go to products real quick. While we're waiting, we can talk a bit. So I have these two, or have one of those and getting the other. That wouldn't be fun. I want that one. PCIe 4 one I also want. Look into ordering these sometime. The center one would be fun, but sheesh, for $130, give me the PMod one and I can just stick PMods on it. Okay, so this board, thing of note, let's see. Go to the data sheet, right? Does the data sheet tell you? So these are, your standard 2.5 millimeter distances. These are your they're just your 2 millimeter distances. So if you do get this, I'm going to suggest, I'll probably put these in the description later, right? So you'll want to get these from Adafruit. So these are your 2 millimeter pitch, and you can just break these off. It's 20 by 2. So this is 20 by 2. So you need to get the 2 millimeter pitches for this board. And then also at Adafruit, they have these 2 millimeter to 2.54 millimeter cable. So you got 2 millimeter sizes over here, and then you got your 2.56. This is great. They actually have it for this board, but this will work great, I think, for this board. Let me order them. Let me solder it on. Make sure it works before you commit money. Okay, next on the transceiver side, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 connectors, or 9 sets of 9 pairs of UFL connectors. I'm wondering if that it's probably 2 millimeter as well. So let's say you should get two. You should also get some of the 2 millimeter headers for this. The 2 millimeter headers are probably for all these boards. But for that, I am thinking of getting. I looked around for a bit, and I think I picked on this product right here. So this is a 20 millimeter, 20 centimeter cable. It handles up to 6 gigahertz. It's about as best as you can see in this one. There's some 8 gigahertz ones, but they're not really usually out of stock or whatnot. So this is probably the UFL connector I am buying. I'm a little afraid to buy too many of them because it jumps up pretty quickly. But at least 6 of them so I can do some eye scans on the breakout cards. I would like to order this, but I have other stuff I should work on before I start just, keep ordering more boards and spend little to no time working on it. This one would be good to test out. Is that JTAG? or doesn't have JTAG. To test out, I'll look at that real quick. To test out Ethernet, this would be good. I could get an SFP plus connector as well to test out this. Is this JTAG? What's the JTAG connected to? No way. I'm confused. It says JTAG, but it's not connected to JTAG. RTX. What's the JTAG connector? Energy specifications. That's repositories. Not helpful. Ah! So, is the JTAG a lie? What's the JTAG doing there? That JTAG isn't real. That JTAG's not connected, I can promise you that. What are you doing with the JTAG there? They don't even talk about it. The JTAG's a lie. I'll have to pop open the schematics. Let me pop open the schematics on their proprietary website. I hate this. Yeah. So let us go look at that schematic. No, those aren't useful. Those aren't. I have no clue what that JTAG does. No clue what that JTAG does. Cool. Next thing is the PMod. PMod's gonna be super useful. Why? Because we have Digilant, right? And projects, the PMods, right? We got a bunch of PMod stuff. This would be great. We can put SD cards on it. We can put wireless modules on it. PMod hat for Raspberry Pi. Yeah. So give me PMod. We can do anything. Ooh, that'd be fun. Give us 6 pages of this. Great. Function. Ooh, what display ones do they have? A simple one. Do I have that laying around? I may have one. Oh, I have the hat. I have the hat one. It does that. Power. Ooh, power monitor. That'd be fun. Adapters. Servos. Test point. Keyboard. Prototyping board. What else we got? IO. Yeah, we can do some switches. Have some hard switches. Sweet, that'd be great. Ooh, joystick. That'd be fun. Let's make a controller. But yeah, video. Did we have any good video? Any HDMI ports? No, not really. Though, if we go to Icebreaker, right? If we go to the Icebreaker question, Icebreaker PMod video. Oh, HDMI PMod, right? This guy. Hopefully that's a standard distance that matches that distance. And I think it is. So I have one of these. If we get that board, we will test it. Ooh, PMod Hyper RAM. Fun. Get some Hyper RAM. Ooh. Okay, cool. We've looked at that for a great amount of time. So yeah, let's go ahead and open synthesize design real quick. Just want to double check that. Okay, cool. Anything else? What have we got here? We have ADCs and DACs. I don't really got any good thing for the ADC or DACs at the moment. Not good enough in those areas, but the camera is great, but the camera is super expensive. Okay, sorry. Okay, Dr. Ron Kumar, if you're still here, I'm sorry that was a little slow in responding to you. When did that happen? Okay, Dr. Kumar. I would suggest Akira, right? If we wanted a board for robotics, we would probably look at the Akira KV260, right? If we want to do vision-based MML and robotics, this SOM is probably a great project. The SOM you can then transfer to your custom robotics control system or cameras or something like that. Vision AI. This is where I would say if you're doing robotics and vision-based vision. Hopefully you're still watching. I wish I could send this directly to you, but I'm gonna put it on the chat and maybe let's see. Can I do an @ symbol? Never. I really haven't done this. There we go. Hopefully this reaches you. Try the Kira KV260. I don't think that worked as well as I hoped. I think the space in your name kind of wrecked that. If you're still here, cool. The issue, right? What's the biggest issue about getting this board? It's a lead time of 60 weeks. It's fun. It's fun. I have one, but yeah, I bought it like a year and a half ago, and it took a while to come here. It was exciting. I need to use it more. I don't think what's the MIPI. Oh, MIPI cameras. It'll be fun. Multi-DAC, product in development, PMON sensor, receivers. Okay, I don't think that's anything useful. So if we go to the DDR, right? Yeah. So right now we don't have anything set for this, and this is probably going to cause us an error. Let's generate bitstream. And get the error message, and then send the error message to the peoples. Is there any other cool things we could see on this board? Let's see if we can find any other Syzygy products, right? Let's see. PGA. Peripherals, right? See, do you have this is all Opal Kelly, and then we have these two. So yeah, not the best implemented standard. Terribly priced. Oh, that one's. Hey, it's the analog O-scope I asked for. So they got an analog O-scope and a waveform generator. That's pretty cool. Maybe we can go through these sometime. They have these for the Z mod. Well, that's okay. So according to this, we don't have any other things, any other carriers. The butter stick. Vigilance. The pink ZU has it? I want to see what this looks like. I haven't seen that before. Okay, that's what we have. Oh, this is the breakout board for. It has a lot of them. There's still just 6. Butterstick hardware. Oh, we got 3 of them here. Lattice board. I don't have a butterstick. It's an 85F. That's a good board. One transceiver one. Latest releases. Where can we get the butterstick FPGA? Tell me where kits. How you doing over here? Doing off the design. Okay. It's kind of expensive. I already have a few of these. Nice to have a lattice board with that features. How much DDR? Your memory up to 8 gigabits. 2 gigabit, 8 gigabit. Tool rank. DDR3. We'll view the campaign. Yes, we can put that in there. And I want to know about the pink ZU. Did they make a new one? Ooh. I want to get this board. This looks like a nice board. Where to buy? Hey, this is a great board right here. Pink ZU. Oh. Where's the schematics? Give me the schematics. I think I found a board I really want. Got FMC. Ooh, 4 gigabyte DDR. Do we have a PL bank? Started user manual. What the user manual says. What's the lead time on this sucker? An add-on board. Distribution partners. Okay, I like this one. Where's the HDMI? Dude, this would be a great board. I got to figure out the schematics. Okay, that goes. Oh, that would go on that little interface. Sure. How do I buy these products? Digital video solutions. Sure. What's on that board? Sheesh. I don't see it. Not useful. Not useful. They don't give me a price. They don't give me a lead time. How am I supposed to appreciate this? Google Translate. Tell me, what's that mean? To English. Translate English. Where's our little... Where's Google Translate? Why are you not useful? Views. Okay. That's how many views you got? Okay, sweet. This board's impossible. Well, let's go ahead and look at what we got here. 224. So what I want to see is the HDMI. How is the HDMI connected? Is this raw connected, or are they sending it to a? So this is the bank right here. HDMI looks like they have a chip. So let's follow this board right here. Let's follow. It looks like they have. So this is going to. So that's the connector. So this is the raw connector. This connector has the data, and then it's doing something with it. Okay. What is this chip? It's a Texas Instrument chip. Sweet. HDMI retimer, temperature, description. I want technical documentation. Okay. Who owns? Most important question is who owns the? Yeah, you own that. What do you say to our HDMI page 22? It provides HDMI output is provided on upper ports, dual stacked. So I think we get fairly raw things. Do they have the what's that? Do they have the PL hard drive for it? Sorry guys, I'm going on a tangent. Okay, this failed. Let's view the log messages. Okay. I'm gonna copy this message and then we're gonna fix this. So it looks like Opal Kelly does have issues. Ah. So let's copy over last files, right? We're gonna copy over this. These are the minimum change we need to do. So up here. Synthesis is not out of date. Synthesis is fine. So we go to design runs. We say, ha, I force you up to date. It's fine. And then we'll generate bitstream. Okay, back to our discussion into this board that I really like. Images, board files, started guide. How are they generating the HDMI? So they have it in the board store. They have it in the board store. Okay, so if I go to the pink GitHub, right? Are you telling me that I go to boards right here? Where's the pink ZU? Pull request. Do we have pink ZU somewhere? Where is it a branch? I don't see it here. Code. Do we have it in a branch? Image. Branches. I do what? Pink dash ZU in this organization. Oh, we have it here. Okay, cool. What are you doing for the HDMI interface? That is the most important thing. Where's this? Yeah, it's okay. Base. So we got here. What are you? We have these. So Xilinx, Vidify controller. Is this free? Does it require a license? Is it unlicensed? We have new HDMI modules. Hey, wait a minute. Wait a minute. Are you telling me that they add something? Video timing controller. We're looking for the PHY. Where's the PHY? Not in here? Does it require a license? Do I have to download it? This is not hardware. This is new. License. You say that. Okay. Yeah. Requires a license. They're using the licensed HDMI device. Okay, back to here. That's the same thing as the ZCO104, which is a great board. You can get a ZCO104, go for it. How delayed is my video? Sheesh. Okay, we're going back here. How long it takes for my video to come up? Ooh, looking at the live stream here, guys, and it's kind of delayed. Oh well. Okay, so we're just gonna kind of watch this log file. If it builds, we'll call it a success and end of the video. If it doesn't build, I don't think there should be an issue. It should build just fine. So we'll just watch this run, I guess. If anyone has a question, feel free to shoot. Any FPGAs coming out, right? Like, let's see. You can check out group gets, right? FPGA. Group gets FPGA. Oh, OpenSeg. Is this open? I don't think I'm getting this one. What? This was, they called an eFPGA. And you look at it, only 64 CLBs. I'm not getting that. Get lamb. Any FPGAs? FPGA. Or Orange Crab's an FPGA. Crowd supply FPGA. Look at that. Anything interesting? I haven't looked at that one. Got that one. Any interesting? The Luna. Maybe we'll see the Luna. Luna is one I was interested in, but didn't get that one. I have a bunch of basically those. Bought one of those recently. That's kind of the forefather of the board we currently have. Luna. Yeah. Luna's a cool one. Wouldn't mind getting a Luna. It's a low rate though. I wish they had high rate transceivers going to that. Any pre-launch FPGAs? There was a PolarFire SOC one stage right here. I'm interested in this board too. be a fun board. How did they stack? Oh, they just did that for funsies. Yeah, that seems like a really cool board. That is definitely a computer. So these were USB-C PCIe connectors. So you can have a ton of PCIes connected to your PolarFire FPGA. Really like that board. What are we doing here? Oh, it generated the bit stream. So we'll probably close this real quick. Okay, let's see. What FPGA are we running here? 5K LUTs, that's really tiny. I guess you're just using this to do some pre-processing before you send it to another device. Yeah, let's say terribly interesting. Luna, it's great, but if we go down to diagram anyway, I'm not using supports. They have FTDI chips that are manhandling the USB ports. I want the USB port to go directly to the FPGA. I want the FPGA to get raw USB connections and whatnot. And they don't really do it on that board. Okay, so we're gonna go back to here. So we finished. So okay. Remind me later. So to get my this is what the minimum I had to do. I had to zoom in. Edit. Can't zoom in. Should probably use a different IDE. This is the minimum I had to do to get the board files to work. Send a quick email to port pages. But yeah, I think that's good. It looks like my video is almost 5 minutes delayed. Sorry. I guess that's it. We didn't miss any videos, but okay. I need to fix my USB-C. Yeah, so what's next for this board? Next for this board, we're going to learn how to do the raw JTAG over USB-C. Maybe we'll start that tomorrow. We'll find out. Thanks for watching. Hope you can get this board file working when you want to.